Dear colleagues, I would like to present to your attention a presentation solving incorrect problems in conditionals of approximate data with singular matrices. A significant number of applied problems include as a component part of finding the solution of the system of linear algebraic equation. Many applications are reduced to the least square and the weight least square problems. Characteristic features of slayers that arise in certain tasks is their large order. In some models, the order of the slayer matrix can reach several million. At the same time, the requirements for high-performance computing are far ahead of the capabilities of traditional parallel computers, even without taking into account the multi-core processors. Let us consider the solving of incorrectly formulated problems with approximate data and sparse matrices. Let's consider a system of linear algebraic equation 1 with a sparse symmetric positive semi-definite matrix of order n and rank k. Let us also consider this layer with a perturbed right-hand part 2, 3. For problems 1, 2, we can write for 5. The problem 2 will be considered well conditioned if the properties of the problems and the error of the initial data allow us to obtain the specified accuracy epsilon of the solution. That is, if conditional 6 is satisfied where H is conditional number of the matrix A. Let us consider a three-stage method for the solving of the problem. For an arbitrary chosen parameter alpha, the following step of the algorithm are performed. The three-stage regularization method consists in performing the following steps. Sequential solving of two slayer 7, 8 with the same positive definite matrix A plus alpha E. Calculation 9 and 10. Verification of the fulfillment of the inequality 11. If the inequality is fulfilled, then the requirement accuracy epsilon is achieved at the selected value alpha equal alpha 0. If the inequality is not fulfilled, then the new value of the shift alpha equal alpha 1 is determined by the formula 12, and step 1 is repeated with the matrix A plus alpha 1E. A new approximation U is calculated, which ensures the required accuracy epsilon of the normal pseudo-solution. The advantage of the three-stage regularization algorithms are enhanced for matrices of the special structure, for example, band matrices. Consider the error of normal pseudo-solution of problem. If conditional 13 is satisfied, the error of the approximate generalized solution of this layer with the symmetric positive semi-definite matrix is estimated by the value 14. Consider the problem of weight least square problem 15 with positively defined matrix of weights and perturbed problems 13, 17, 18. The weight vectors and matrix norm is defined at 19. We represent the norm of the residual in the form 20. Thus, we arrive to the problem 21. Suppose we have in general incompatible system of linear algebraic equation 22 and the perturbed problem 23. The three-stage regularization method for solving the VLS problem involves performing steps 1, 3 as previously described. For the error of weight normal pseudo-solution holds is the following estimate 31. Consider this layer problem 32 with a symmetric positive semi-defined sparse matrix A of order n and rank k. The solution to such a problem exists and is unique. The ideological prerequisite for the use of parallel calculation in the processing of sparse matrices of arbitrary structure is the preliminary rearrangements of the structure of the original matrix, in particular by the method of parallel sections. Which brings the matrix to a border block diagonal form 33, where P is a matrix of permutation and blocks AEE, APE, AEP maintain a sparse structure. The most effective direct method for solving such a problem is, as is known, the Nikolaevskaya method. Solving the system consists in solving sub-problems, triangular development of the system matrix 32, 35, and solving two layer with triangular matrices 36, 37. Obviously, from the point of view of computer implementation, the three-stage regularization method is reduced to LLT factorization of the symmetric border block diagonal positive defined matrix A plus alpha E, a multiple solution of the system of linear equation with triangular block sparse matrices L and LT. We will get a block version of the algorithms of the direct method based on LLT factorization. It's a factorization of the diagonal block AEE, modification of the border block LPE, finding the product GE, updating last diagonal blocks APP, and factorization. For block diagonal matrix factorization algorithms are implemented as follows. Simultaneously in all CPU, we implemented the block factorization algorithms AEE. At the same time, we modify the border blocks LPE in all CPU, and find the product GE in CPU pair using a multi-collection GE. We modify APP. Depending on the structure of the diagonal blocks, algorithms for their development are used for dense strip matrices or skyscraper matrices. The next slide shows the forward and backward substitutions of the algorithms. This slide shows the technical characteristics of the computing system where the developed algorithm software was tested. Here you can see the results of numerical experiments. Numerical experiments were carried out on the following sparse matrices, and the characteristics of which are given in the table. Figure 1-2 shows graphs showing the execution time of the algorithms and the speed up of the obtained accelerations. We can make some conclusions. For the first time, an algorithm for solving inconsistent system with a generative border block diagonal matrix with a guarantee of the solution accuracy of massively parallel system is proposed. A three-stage regularization method for the least square problem and weight least square problem with a symmetric positive semi-defined matrix was developed and extremely investigated. The main difference, novelty, of the three-stage regularization method from other regularization methods, for example, Morozov, consists in automating the selection of regularization parameters alpha, which ensures obtaining a solution with a predetermined accuracy. The three-stage regularization method allows preserving the band structure of the matrix, unlike other regularization methods, and significantly reducing the number of arithmetic operations. An algorithm of the direct method for a linearly square problem with border block diagonal matrix was developed. Thank you for attention.